This is a combinations question where we're being asked to work out what value of n would fit this particular equation. So we are aware that any combination NCR is going to be n combination factorial, divided by r factorial, and then difference between n and r factorial. So here my n value is n plus 1, so we have n plus 1 that's being put to factorial, and we're dividing that by 2 factorial multiplied by the difference between n plus 1 and 2. So if we tidy that up, now we can also expand out some of these as we go along. So the key thing is n plus 1 factorial could be seen actually as, if you wanted to, you can multiply it out straight away. It's n plus 1 multiplied by 1 less than that, multiplied by 1 less than that, multiplied by 1 less than that, all the way down to 4 times by 3 times by 2 times by 1. On the denominator, we've got 2 factorial, which is 2 times 1. And now, just very quickly, in terms of what we have here, this bit here is equal to, as an expression, if we tidy it up, it's basically n minus 1. So what we have is n minus 1 factorial gives us n minus 1 multiplied by n minus 1 less than that, multiplied by 1 less than that, all the way down to 4 times 3 times 2 times 1. Okay, so that's that factorial there. So we have some factors on the top and the bottom that are common and therefore can be cancelled each other out. So the 1, the 2, and the 3, and the 4, and the 5, and the 6, and the 7, all the way up to n minus 3, n minus 2, n minus 1. All of those are cancelling each other out. And what we're left with as to simplify this, we've got n plus 1 multiplied by n, and that's all divided by 2. So going back to the original question, it's got to equal 28. So we can now solve that as a question. So I'm going to multiply both sides by 2. So 2 lots of 28. 56. I can expand the brackets. I can also make everything equal to 0. I bring the 56 on the other side. I now have myself a quadratic, which I need to solve. So I get 2 answers from that quadratic. I get 7 and minus 8. N has to be a positive number, therefore I'm able to reject the negative value and simply say then n must equal to 7. And I would contend if you were to have 7 in there, i.e. if you were to do 8 combination 2 on a calculator, you would find that you would get 28. So it fits, it works.